Hello everyone, I'm Chen Xiaowen. Today I'm going to report my topic, which is Theory 6 Oxidation and Coagulation for algae organic matter removal and DBPS control in drinking water treatment. Okay, now I'm going to report my paper background. In recent years, rapid population growth and improper water resource management and increasing human activities has accelerated the depletion of freshwater resource worldwide. At the same time, excessive nutrient input into lake and reservoirs have led to eutrophication. The presence of algal cells algal organic matter, which is ALM, in drinking water treatment can reduce treatment efficiency. In Taiwan, pre-oxidation process such as pre-chlorination or ozonation are common used to low algal cells and ALM levels and improve downstream removal performance. However, however, improper pre-oxidation can increase the formation of harmful disinfection by products, which is DBPS, from ALM, posing risks to drinking water safety. Therefore, alternative pre-treatment methods such as UV irradiation and ozonation combined with coagulation have been explored to enhance ALM removal while reducing DBP formation. Okay, now going to report about ferric 6 characteristics. Ferric 6 removes contaminants through oxidation, disinfection, and in situ coagulation with ferric hydroxide, further enhancing removal via combined oxidation coagulation, and also very free produced by ferric 6 reduction reduce the negative charge on the surface of algal cells through charge neutralization, promoting the aggregation of algal cells. And there is a list that report shows the at different pH, how will the ferric become an effect to the organic matters. And the first, which is the pH at 10. Ferric 6 has the greatest stability, but also means that uh, he was weak oxidation capacity that also show a half-life of 100,000 seconds at pH 10. But at pH 6, it will rapid cell decomposition of ferric 6 at lower pH and half-life of just half 100 seconds at pH 6. But for coagulation at pH 10, the FeOH3 and the algal cell surface will have the same charge, and coagulation will be hindered by electric repulsion force, thus reducing the removal rate of algae. And at pH 6, ferric 6 enable simultaneous oxidation of contaminants, and formation of ferric hydroxide for coagulation, enhancing removal efficiency. Okay, now I'm going to introduce the ferric 6 oxidation mechanism. Okay, for the mechanism of ferric 6 oxidation is generally divided into two stages. The stage 1, the ferric 6 oxidatively damages intracellular organic compounds of microalgal cells, leading to cell inactivation and toxin degradation. And stage 2, oxidative stress induced by ferric 6 disrupt the extracellular polymeric substance EPS on the algal cell surface, weakening its protective layer and enhancing subsequent removal. And the figure shows the ferric 6 we add into the algal cells water, and it will release the electron for release 1 or once release 2 electrons. And when it releases the electrons, and it will oxidize the algal cell surface at the same time. So and that's why ferric 6 can use the oxidation to remove the algal cells. Okay, and we just introduced how ferric 6 oxidative others or the organic matter, and now I'm going to introduce the ferric 6, how ferric 6 affect in the coagulation. Okay, and its mechanism is ferric 6 reduced to ferric ions and immediately hydrolyzed into insoluble ferric hydroxide, colloidal precipitates, acting as an in situ coagulant that efficiently removes algae and organic pollutants through charge neutralization, sweet flocculation, and complexation. And second, ferric 6 oxidizes algal cells and is subsequently reducing to ferric free, forming ferric hydroxide flux that remove dissolved organic matter through adsorption and sweet flocculation. And here is the formula that how ferric 6 add into the water, and it will become FeO4, and which combined with the water, it will become ferric free, sorry, and it will release a lot of OH radical. And ferric 6 combined with the water, and it will become FeOH free, and which is the mainly coagulation agent. And the total formula will become like the final one here, down here. And as the figure, the FeOH free will absorption the microalgals or other matters can make them become a big flock and settle down. Okay. Okay, and now I'm going to introduce the effect of pH on ergotoxin removal by ferric 6 coagulation. At different pH levels, such as the figure middle and the right side, the zeta potential increase closer to zero under weakly acid conditions. The middle one, the pH 5.5, indicating better charge neutralization. Consequently, the removal efficiencies of ergotoxin and turbidities were significantly higher under weakly acid conditions compared to neutral or weakly alkaline conditions. Yeah, so we can see the figure left side, the zeta potential. You can see the pH 5.5, the zeta potential is more closer than the pH 7.5. So that can show, before we say about we talk about when pH lower become acid, weakly acid, and the ferric 6 oxidation will become more powerful. Yeah, and now we can see the middle figure and the right side. We can see the turbidity or the toxin. They both are the pH lower one, pH 5.5. One is better than pH 7.5. Okay, now I'm going to introduce the effect of ferric 6 oxidation on DBPS. By restricting natural organic matters, ferric 6 significantly alter DBP precursors, thought selective oxidation, and in situ Fe3 coagulation, while effectively mitigating carbonations DBPS. It triggers distinct transformation pathways across species. And there is a list that the paper shows that when they add ferric 6 into the alga's water and do the coagulation, after they add the chlorine inside, and that will and that shows that THM, the trend decrease as the ferric 6 dosage higher, and HANS also. But the CH at the first they increase, then decrease. But on TCNM they always increase. And right now I will say why the ferric 6 affect them, because the ferric 6 directly destroy alcohols, phenols, and aromatics, cutting off the precursor to block post-chlorination reactions on THMS and HANS also. And on CH, Fe6 transform alcohols into intermediate aldehydes at low doses, increasing, and at that time that CH increasing, but further oxidize them into acid at high dose, they will slowly decreasing. And on TCNM, ferric 6 oxidize amines into highly stable nitrogens intermediate, which rapidly convert into TCNM upon post-chlorination. And there is my conclusions. Ferric 6 inhibits surge oxidative capacity at pH 5.5 and drive in situ coagulation via Fe3 charge neutralization, significantly improving Algae and turbidity removal. And the second is ferric 6 destroy alcohol and phenols to mitigate THM, HAN, and high dose CH, but cause incomplete amine oxidation into nitrogen intermediates, forcing an abnormal TCNM increase. And thanks for listening.